Hello everyone, my name is Rohit Singhal and we have started in the previous class the chapter redox reactions. Till now we have studied what is redox reaction, comprised of two words, reduction and oxidation. We have studied the different categories when the reaction is termed as oxidation reaction and when the reaction is termed as reduction reaction. So, if you remember the last example we have discussed the reduction reaction case, that was the reaction of HgCl2 with SnCl2, that gives Hg2Cl2 plus SnCl4. I have balanced out the equation 4Cl 6Cl. Okay. So, what we have studied in this reaction is that there has been addition of an electropositive element. That means, this mercury chloride has been reduced because of an addition of mercury. This has been reduced, whereas you must see in this case only that there has been in this stannous chloride there has been an addition of chlorine, and chlorine is an electronegative atom. So, what we are seeing in this reaction, that one part, because an electropositive element mercury has been added, that we are saying is an reduction reaction, whereas in the same reaction what is happening, an electronegative element has been added to the second molecule, that is SnCl2. The 2Cl has been added and we know this addition of any electronegative element, we termed it as oxidation reaction. So, what I am trying to say here is ki oxidation reactions and reduction reaction are two complementary things, one goes with the other. It is not possible that only reduction reaction is possible, it is not possible that only oxidation reaction is possible. Whenever there is, you must note this thing, whenever there is any oxidation reaction happening, whenever there is any oxidation reaction happening, there must be a counter, reduction reaction to it. Or vice versa. That means, whenever there is an oxidation reaction happening, there will be a reaction that is called reduction reaction will be happening. Similarly, reduction happening or there will be an oxidation reaction to counter that equation. That means, both the equation corresponds to each other, both the equation goes always together. That means, whenever there is oxidation there will be reduction, that is why we have termed the combination, that is why the combination term is used. That is redox reaction. That is why this kind of reaction are called redox reactions. Now, you must be wondering one thing, that maybe I have taken one such example, that where this both oxidation and reduction has been happening and in the previous cases there is no such case. So, let us discuss one or two case. Okay. One of the first examples I have discussed with you is the magnesium reacting with oxygen to form magnesium oxide. Okay. What I have told you is that this magnesium, an addition of oxygen has been happened, addition of oxygen, and I have told you this is an oxidation reaction. This is true, this is an oxidation reaction, but right now we are seeing from the magnesium perspective. Let us say we see from the oxygen perspective. What oxygen has been happened? What has happened to oxygen is, in oxygen O2, what is happening? A magnesium has been added. It is an an electropositive element, that is magnesium has been added to the oxygen. That means, an addition of magnesium. And what is magnesium? Magnesium is nothing but an electropositive element. That means, what I am saying, that magnesium has been reduced, sorry, oxidized. Magnesium has been oxidized. What we have done, that in this reaction is magnesium is getting oxidized and oxygen, this is getting reduced. Okay. So, that means, in every reaction, in every redox reaction, one part, or let us say one element, or let us say one element and other will get oxidized. Now, this is the important thing to remember, that oxidation and redox reaction can't go separately with each other, they go always together. There will be oxidation of one part and reduction of another part, and that is why we have combined the two terminologies to give one terminology, that is called redox reaction. Okay. Now, you have studied addition of oxygen, removal of hydrogen, electropositive, electronegative element. Now, we will discuss these redox reactions. Redox reaction in terms of electron transfer reactions. We know कि whatever reaction happens, reaction that the basic of the reaction, any reaction is an electron transfer. Okay. So, we will study the redox reaction in terms of electron transfer. In chemical bonding, you have already studied a few of things chemical bonding. So, I am taking a few examples first of all. Let us say Na plus Cl, NaCl. Okay. Cl2 gas we have, and let us say this is the value. Okay. Okay. This is one of the reaction that solid Na reacts with Cl2 gas to form solid NaCl. Okay. This is one of the reaction, the reaction has been balanced. Okay. So, now we see whether this reaction is redox reaction or not. Okay. We will first see the sodium. What happening to sodium? Sodium becoming NaCl, that means an electronegative atom Cl has been added. So, that means addition of Cl. Addition of Cl means oxidation reaction. What happening to Cl2? An electropositive element sodium has been added, that means addition of sodium if happening, that is a redoxation reaction. That means, this reaction which I have shown is an example of redox reaction. Okay. But we all know that sodium chloride, if I say we can write sodium chloride what as Na plus and Cl minus. Okay. We know this is how the sodium chloride exists. Na is in plus oxidation, plus 1 oxidation, and Cl minus, Na plus and Cl minus is the thing. Now, if we see this reaction from the electron transfer point of view, this is writing, I am again writing is Na plus Cl2. Okay, let us write Na plus Cl2, it forms Na plus Cl minus. Okay. Now, see this Na, what is the charge of Na on Na? 0. What is the charge on Na of this plus 1? Okay. That means that one Na, what is happening to one Na? One Na is losing one electron. Okay, it is going from 0 to plus 1 charge. That means, okay, loss of how many electrons for one sodium? One sodium is losing one electron. How many sodiums we have? Two sodiums. That means, loss of one electron for one sodium, but loss of two electrons. Total loss is 2 electrons for 2 sodium atoms. Okay. Similarly, see the case for chlorine. The charge on chlorine is 0, the charge on chlorine here is minus 1, the charge on chlorine here is minus 1. Okay. That means, one Cl atom, carefully see what I am saying, one Cl atom is gaining one electron. How many Cl atoms we have? 2 Cl atoms forming a chlorine gas. That means, one Cl atom one Cl atom gains one electron. That means, total gain of electron will be how much? 2 electrons for 2 chlorine atoms. So, we are seeing in this reaction is, that means, the sodium is losing an electron, 2 sodium are there, they are losing 2 electrons, and chlorine in total is gaining the 2 electrons. That means, there has been a electron transfer of, there has been a transfer of 2 electrons. What is happening is transfer of 2 electrons, that from one atom to another atom, that 2 sodium atoms are removing 2 electrons from its outer orbital, whereas 2 chlorine atoms are gaining 2 electrons. That means, there has been overall transfer of 2 electrons from sodium to chlorine. So, what we are saying, okay, what we have studied, this sodium, I have said that this sodium is having one electronegative element with it. Okay. This sodium Cl2 NaCl. Okay. So, what I have said for till now for sodium is, it has addition of one electronegative element. For Cl2, it is addition of one electropositive atom. From electron transfer, what we have studied? What is sodium doing? Sodium is losing electrons. It means, loss of electrons. And what chlorine is doing? It is gain of electrons. That means, we are already aware that sodium is getting oxidized because of addition of electronegative atom. So, what we can say, a new terminology we can define for oxidation and reduction is loss of electrons in terms of electron transfer, I am saying, and gain of electrons. So, I am saying loss of electrons will be termed as oxidation reaction, gain of electrons will be reduction reaction. Now, please do not confuse that why there are so many definitions of oxidation and reduction reactions. It is just to have a broad, to have all kind of means have a knowledge of from every aspect, that means, okay, if you only know one thing, that is addition of oxygen or addition of hydrogen, that will not be sufficient, because there has been no addition of any oxygen or hydrogen here. If I will say electropositive element, electronegative element, that is fine. But why we are having the electron transfer processes here is because whatever reaction takes place is basically the transfer of electrons from one thing to another. So, just to clarify things, just to better understand our concept, we are also describing this oxidation and reduction terms in terms of electron transfer things. So, I am saying this oxidation reaction is loss of electrons, that means and when an element loses an electron, that when an element loses its electron, it is said to be oxidized. What is said to be oxidized, and the reaction oxidation reaction. Similarly, when an element gains electron, it is said to be reduced, and the reaction is known as reduction reaction. Okay. So, till now you must be have a bit clarity about what is oxidation, what is reduction. Keep the earlier things in mind a bit, addition of oxygen, removal of hydrogen, electropositive, electronegative, that is simple, keep that thing in mind. And this thing, that loss of electrons, if someone is losing its electron, it is getting oxidized, if someone is gaining electron, it is getting reduced and called reduction reaction, and the combined we say redox reaction. You can also I am saying this Na plus Cl2 reaction only. You can classify this reaction into two categories. We know this is a redox reaction. Okay. This is a redox reaction. This redox reaction is comprising of two things, oxidation and reduction. We can separately deal with this reaction. How? That Na is gaining one electron, or let us say because 2 Na are there, if I am balancing out the equation. So, let us say 2 Na gaining 2 electrons to form 2 Na plus. Similarly, Cl2, 2 chlorine atoms in Cl2 gas gaining 2 electrons to forms Cl minus. Okay, I have by mistake I have written here gaining electrons, it is actually like this. Okay. So, left hand part is the oxidation part, this is oxidation and this is reduction. So, what I have done is I have splitted the complete reaction into two halves, one is oxidation part, another is reduction part. In the science terminology, we term it as half cell. These are two half cells of a complete reaction, 2 half cells. This is a complete reaction, complete cell reaction. This is called complete cell reaction. If this is a complete cell reaction and these are two halves, so which half this is? This is oxidation half cell. This is oxidation half cell, and this one is reduction half cell. Okay. So, the entire equation is called complete cell reaction. We have splitted the complete reaction into two halves, one is oxidation reduction called half cells. This left one is I have described the sodium losing the 2 electrons, that is oxidation half cell. The right hand side is the reduction half cell. These are called two half cells for a complete cell reaction. Okay. So, it is just because I have done these two half cell reactions, we do this because just to simplify our things, that we can separately discuss oxidation and reduction and then we can combine it afterwards we have discussed it. So, the next things we will discuss in the upcoming lectures. Till now, thank you so much.